Your disposal. I'm going to take that as a go. Welcome everybody. Thank you for coming. This is a very special moment for me, because one of the very first things I ever read, long before I thought about doing a PhD, long before I even knew what a computer was, I read this funny paper called 20 Things to Do with a Computer. And the idea that there was even 2 things you could do with a computer was foreign to me. I belong to that generation of maths-trained people who were told that the computer is the work of the devil, and if you give the computer something to do, your brain would atrophy and terrible things would happen. So 20 things to do with a computer, and that didn't count Twitter, Facebook, Photoshop. There's quite a few. Imagine now writing a paper with that amount of vision. So it's with great pleasure that I introduce Cynthia Solomon. I've been trying to negotiate with Cynthia exactly how this session would play out. And believe me, the best thing to do is what I've done, which is just leave it entirely to Cynthia. So over to you. Thank you.
I'm not the greatest speaker in the world, so bear with me. But I feel very, very honored to be here to talk with you. And
Keep going.
I want, when I think about my history, I think about how fortunate I was to work with both Seymour Papert and Marvin Minsky. Whoops. There's my mentor, Seymour Papert. And I had another mentor, and that is Marvin Minsky, who was Seymour's closest collaborator for over 20 years. And he was kind of a silent partner in the development of Logo. And I'll point out some things that happened. I mean, Marvin, Seymour, and I, and a couple of other people started a company in the mid-'70s called General Turtle. Later, that one didn't do so well, so we started another company called Logo Computer Systems. Marvin and I didn't stay in the company, but we were part of the formation. So that's to say that Marvin has always been an integral part. And the day before I came here was Marvin's funeral. And personally, it leaves a great gap in my life. For those of you who don't know, Marvin Minsky was one of the founding fathers of artificial intelligence, of how to think about making computers think. And Seymour and Marvin were sort of enmeshed together for 20 years. So what was interesting to me, because I'm not an AI person, was the interconnection between thinking about how to make machines think and how children think. There was always a swapping of ideas. Seymour loved to say he was going to stand AI on its head. He was going to stand Piaget on his head. And sometimes he actually did. Anyway, here is...
How did you meet Seymour?
Marvin talking about...
It was at that meeting where we both gave the same paper in England. It was a reinforcement by changing probabilities of, I forget what the application was, but we had both proposed a kind of reinforcement learning mechanism, and with exactly the same results in 2 separate papers. And then Seymour decided to leave Piaget, where he was in charge of research for several years, and come to MIT.
Now, that was in the summer of 1962. There was a conference in England that Seymour and Marvin intersected with. And I came along. How did I meet them? I came along and met Marvin in 1962 when I was 2 years old, and became his secretary. Why? Because being a modern woman, I wanted to learn to program, and where could I go? I had gone to typing school. When I worked for Marvin, he typed faster than I did. So typing school wasn't very helpful. Anyway, it was my introduction to computers and to the kind of thinking about computing that Marvin's students and Marvin shared. So it was very, very profound for me. Here is my favorite picture of Marvin and Seymour. This was, I think, 1971 or 2, and they were, they had written this wonderful progress report on artificial intelligence, and that was on the back cover. Now, here are some of my favorite quotes from them. I love the one that Seymour sort of expanded Dewey on, which is kids learn by doing and then thinking about what they do. And the other quote of Seymour's that resonates all the time with me is that you can't think about thinking without thinking about something. And once you get over the parsing, it really makes sense. And then Marvin is well known for this following statement, which is you really don't understand something unless you understand it in multiple ways. And this is expressed in multiple ways. So if you surf the web, you would find different embodiments of that quote. One of the things that Seymour and Marvin together, and Jose mentioned it in his talk, started thinking about the mind in the sense of a society of little agents, all of them kind of dumb, but together with the appropriate administrative functions, were very smart. And so here's the Pappert's principle, which if you looked in Society of Mind, you'd see. And it says, some of the most crucial steps in mental growth are based not simply on acquiring new skills, but on acquiring new administrative ways to use what one already knows. And for Seymour, this relates very much to Piaget and to how children develop like conservation, that they have opposing views and eventually they collect the data, they collect the information, and they have a good administrative society. Marvin explains it. Marvin was great, so was Seymour, at making things, taking complicated ideas and making them pretty simple. So the way Marvin explains Pappert's principle is a mind can't really grow very much merely by accumulating knowledge. It must also develop better ways to use what it already knows. Now, in a 1970-71, I think it got published, but it was written 1970, Seymour and I wrote a paper. Actually, he did the writing and I did the work. How's that? He's a fabulous writer, as you probably know. And Marvin is equally fabulous. So what a team they made. Anyway, we had this paper, 28 Things to Do with a Computer, and I sort of modified it and have listed 20 things you can do today, maybe. But this is, I love these pictures. Seymour hugging a floor turtle, and Marvin with the arm that could stack blocks and unstack them. Seymour and Marvin, when their early research was on vision, getting the computer to recognize the blocks so that the arm could then go and pick it up and so on. It was very, very exciting in the mid-60s and 70s at the, the other thing is eventually they became co-directors of the MIT Artificial Intelligence Group, which then became the Artificial Intelligence Laboratory. And Marvin liked to say it was great being a co-director because nobody had to make a decision. So the first thing of the 20 things is we had to create a programming language. And the way Logo started was I had finally become a programmer thanks to all the graduate students in the AI lab. Marvin got me my first internship job where I was doing programming in Fortran. But very soon afterwards, I joined Bolt Beranek and Newman and joined Wally Feuerzag, who was had just been given the position of education director. And at the same time, Seymour became a consultant. Now, the way that happened was Danny Barbro, who got his doctorate in the AI lab, and both Seymour and Marvin were on his thesis committee, became head of the AI group at BBN. And Danny was my buddy, and I called him and said, Seymour needs some extra funds, hire him. And so he did, and he introduced him to Wally. And so that began the collaboration. We thought of we thought of a Logo as Baby Lisp. We all had a Lisp background. And I don't know how many of you know Lisp, but I won't go into it now. It's a list processing language, which is why it was called Lisp. And believe it or not, it's still being used. And what we thought of was the objects to play with would be words and sentences, things that kids already were doing. So anyway, where am I? Oh, so that's what I thought I had put that slide on. The underlying ideas were procedural thinking, debugging, talking about what you were doing, and having objects to play with. I think these were the four, and have continued to be, the four fundamental ideas that we were after. So now we wanted to create constructionist activities, make sense by making things. The first year-long class we had was with 7th graders at a school. In those days, it was a junior high school. They no longer have them. They're now middle schools. But we had 7th graders, and they were chosen because on their test scores, they were average. Some were below average, some were above average, low average and high average and middle average. Initially, I wasn't the teacher. We hired a teacher, a math teacher, a really good math teacher. And I think I went off somewhere for a while. And when I came back, I visited the classroom, and I was rather shocked. And the reason I was shocked was because Seymour and Wally observed, but didn't say anything to this wonderful teacher. And she taught what first did and how you could do but first of a word and then first of that. And by the way, we didn't have turtles then. So I was aghast, and I told Seymour I was aghast. So the next thing that happened is I became the teacher. And Seymour became my co-teacher. So he would, the class was 4 days a week, and Seymour would come out maybe twice a week. And so here is the class. We had Model 33 teletypes and Model 35 teletypes. I bet you don't know what that is, but there they are. And the time-shared computer was back at BBN, and it was by then running on a PDP-1, Digital Equipment Corporation computer, the favorite of the day, I think. Here's Seymour and me talking to a young lady about helping her debug her stuff. Now, this young lady, what's interesting is about 10 years ago, she called Seymour's office. Maybe it was 15, I can't tell time. And she asked if there was anything like what she had for her daughter. So I thought that was a great compliment. Anyway, there's a better picture of the teletypes. And here's Seymour talking to this young lady, helping her debug. And this is what she was being debugged. She was working on a random sentence generator. And this was very surprising. The kids were shocked that it mattered how you categorize words. Because their first iterations were nothing like this. They were just ishkabiddle, is what I call them. But anyway, it was, after this class, of course, Seymour decided that we needed something more concrete than playing with words and sentences. And that's how turtles came to be. The model, Seymour remembered in England, there was Grey Walter. I do have a video, but I'm not going to show you. It's online, a cute video of Grey Walter's tortoises running around the room. And here's Marvin. It took him a while before he really acknowledged how important a teacher's role was. Or did you think that wasn't so?
Well, the important idea was to let the child initiate activities because you want to find out you want to exhibit what the child already can do and then modify or build on it. And in the traditional curriculum, you assume the children are blank slates and try to start from nothing. And so if anything conflicts with the skills they already have, they have to subtract rather than add to their abilities. So Pappert's tactics generally were to let the child start to do something and then steer it or encourage it in new directions rather than to have a fixed curriculum and constrain the child and sort of ignore what its current abilities are. This means you get a class of children, all of whom are doing different things, and I guess it's hard to manage that in the traditional classroom.
Okay. So the next thing is making playful learning environments with display turtles, floor turtles, and music. Marvin built that music box. It was a 4-voice music box. We thought it was very important that all aspects were available to children. Textual things, visual things, animation. And there was that yellow canister was the first operational floor turtle. And the little one next to it was built in the AI lab. And the little one had touch sensors. The big one wanted to have touch sensors, but it never got implemented. And there was this government dump yard in Taunton, Massachusetts, and people that had government contracts could go and pour over parts and take what they wanted, and that's where the yellow turtle came from. Here's what the next class we taught was in 1970-71. Oh, by the way, Seymour and I left BBN and took the project to MIT, and the logo group was formed as part of the AI lab. We left because we had a conflict with Wally, intellectual conflict with Wally. People ask me what happened. Wally was a wonderful person, a wonderful father, but he wasn't very steeped in developmental psychology. So there was a schism, and we went our way, and he went his. So Logo had two paths then. Wally was great with middle school, high school, and so on, but not with little ones. So anyway, the next iteration was Seymour borrowed from the applied math department a supernova computer, which was used to drive this display. So kids could use a display turtle and also could do some animation. And anyway, here's Seymour.
Let a child learn mathematics by speaking in mathematics about things that really matter to him. So at MIT, we've given computers the power to turn motors, to make sounds, to draw pictures, and we've found ways of giving children the power to control the computer. Now they'll put their little tunes together to make a bigger one.
Sometimes I get into bugs like this, and it'll, when it was doing it in his mind, the little turtle, the little triangle thing, was on an angle, so it drew the picture on an angle.
A computer-controlled turtle is made to draw and dance by programs so simple that all children invent them in the first days of the course. Thus the child acquires a taste for math power that grows and grows as his projects become more original, more complex, and more varied.
The summer of 1972 is when I met Celia Hoyles and Richard Noss. You weren't born, I'm sorry. Huh? I wasn't born. I know. It was a little egg. And we went there. with a PDP-11 time-shared, dedicated to Logo, a brand new system. Digital Equipment was selling the PDP-11 to the University of Exeter, it happened, and that's where this math education conference was. And also the hackers in the lab had built dedicated Logo graphics things, these big, huge, they were humongous stations that attached. And a group of us went over there about a month before the conference. I had set up, connected with people in Exeter and had some children. So we had 3 or 4 classes of children and all this equipment. And this is a promotional Seymourism, which it's very exciting to read. Do you want me to read it to you, or can you read it? What? I should read it? No, okay. But it's such a Seymourism, I couldn't resist. And what happened, Jean Bamberger was the music person, and some of you know her. She used the music box and did various things with the kids with music. Margaret Minsky was my teaching assistant. Margaret was in high school at the time. And Hal Abelson came over and a few other people. Hal is the one that worked on getting that display programmed and working. And he had what's called a UROP at MIT working under him, but he's the one that designed it. He was intimately, I mean, the reason I'm mentioning it is Hal has written a Logo book, and he's also the author of App Inventor and so on, so, which he says is like Logo, but I disagree. Anyway, what? You're right. Yes. Anyway, it goes on. This was another piece of material. Margaret and I just found this stuff recently, this page from Exeter. Anyway, the thing that we wanted to do was explore turtle geometry as a step toward Mathland. In Seymour's mind, we were always working toward a Mathland. And that's when he wrote the stuff for the Exeter thing. He talked about being in a Mathland. So here are some of my current active coding environments for turtle graphics. So you can, one of the one there I'm going to show you a short on. That one over there is turtle art. This is, what is that one? Scratch. That's why I can't think of it. And this, of course, is Brian Harvey's Snap. And the difference with Scratch and Snap is that Brian likes turtles and preserved a turtle. Not that it points in the direction I would like it to, but at least it points. Now, after the Exeter conference, that's when we formed this company called General Turtle. We were going to, Seymour's brother joined us, he's an engineer, and we were going to make floor turtles galore. And Marvin decided to design and build. You can get the idea, Marvin liked building things. And so this is, let's see if it works. Whoops, did it work? Oh yeah. This is the 2500 that Marvin built. It's a logo graphics machine. It's a vector graphics, and you can see the kinds of things that are possible to do. Now, Brian Silverman, who is probably somebody you've heard of too, he did a simulation of the 2500, and that's what this is. It's online, it's available, it's fun. So this goes on a little bit. What happened to the poor old 2500 is that it was 1974 and hobbyist laptops were, or whatever, desktops were coming out, and they surpassed this. So anyway, it's, I think I'll just, oh, wait till you see the last one. There it is. Isn't that beautiful? Okay. So the next thing was animated graphics, and this, of course, is Scratch. Now, along came multiple turtles. Now, this is Scratch, but before Scratch, there was TI 9900, or the TI 99. And this is a picture of Seymour and some children. That was, TI made a sprite board, and it was the first time we had multiple turtles. You could have 32 turtles zipping around the screen, and it was phenomenal, and in color. Before that, we really didn't have color. Now, the logo group, Hackers, did the initial software, and there was a conflict of cultures between TI and the logo hackers, who were kind of undergraduate MIT explorers. And TI set a deadline. If they had waited 2 days, they would have had a better version, but they wouldn't wait. So, and the guy in charge eventually got jailed. I forget why, but he... So, here, it's very, you know, one of the most important ideas was debugging. Now, here's me struggling with my, how does that work again? Oh, here. Can I get it to go? I can't see. I can't get this to go. Anyway, it was a video. It's enough. It was a video of me debugging that and turning it into some beautiful thing. But see, I don't know how to... Ah, there it is. It's a nice thing, but it isn't what I wanted. So after a lot of fussing, I realized that ARC had already turned the turtle 90 degrees, and that I needed to turn the turtle 90 degrees. So I'm talking too much and I want to get on. So recognizing that text isn't the only thing, I'm hurrying. In 1982, I had the great privilege. I had left OLPC and all that stuff, and to set up, under the auspices of Alan Kay, who maybe you've heard of, if not, ask me a question, I'll tell you later, to set up a research lab in Cambridge, and most of the logo hackers came with me. And so this is the, how do I get this? Well, that's one of the things. I'm sorry, I'm not very adept at this. What? I can't hear you. Well, I don't know. It's supposed to be...
This is a gesture-based finger painting program.
This is Margaret talking.
Wherever I move my finger, I get paint. I can change the colors over here. If I push harder, I get bigger blobs of paint. Here we're especially interested in what are the natural kinds of things you can do with gesture that make it fun to paint. This is a gestural version of a button box for programming. That idea was originated by Radia Perlman at the MIT AI lab. I'm going to teach the turtle how to draw a circle, so I'm going to be writing a program in this button box language. Well, I can say forward and turn right. I can just keep doing that, and as you know, the turtle will draw its way around a circle.
I'll show you the other thing, another thing.
This is the force feedback joystick. We've written a little maze program that lets you find your way around. That little square is you, and you can move around on the walls. You can feel the bumpiness of those steps. And this one simulates a heavy weight on the end of the stick. We also wrote this fishing game. It's got 3 tactics. It wiggles, and it will jerk sometimes, and sometimes it'll just play dead.
And now here's, I skipped one. This is Marvin talking about the demise of, oh, foo. Okay, how do I get, talking about the demise of the Atari
I found that a lot of ideas that I had had that I could never get anyone to develop just fell on the right soil, and I would mention some gadget like this cooperative joystick so that 3 people can play Pac-Man for a quarter instead of 1, and I'd come around in a few days and Max would have actually built the thing, and Gary and Margaret and other people would have written some software, and all of a sudden I would see this thing that I had sort of vaguely imagined, which was working better than I had ever dreamed.
Okay, so now it's time for questions. Is that right?
Well, first of all, it's time to thank you.
Oh.
Somebody, I'm not sure who, said that if you don't know history, you're condemned to repeat it. And I have a feeling it might have been Karl Marx, actually. Whether that's a good or a bad thing, I don't know. Anyway, I think what we've just seen is proof, if proof is needed, that what we think we're standing for, when we have our discussions about what constructionism is, why programming and so on, that we're standing on the shoulders of giants. It was just wonderful seeing Marvin and Seymour, and Seymour's beard and dark hair and so on. Okay, so what I suggest is that I'm sure there must be questions and thoughts and comments that you have. It would be great if we had 5 or 10 minutes for Cynthia to answer those questions. And then please stay around because we're having a rather special event that will happen around 10 o'clock. So is anybody, Celia? No, you're not switched on. No.
Come on. Am I on? Yeah.
Yes.
Thank you, Cynthia. That was absolutely wonderful. And you've now come to the Constructionism conference several times. And looking at that, when I met you in '72, it's a long time ago, what new are we doing now, I'm wondering? You've now watched what's going on all over the world. What is the next thing that hadn't been predicted by you and Marvin and Seymour all those years ago? He talked about music and art and in touch screens. What new are we doing?
Well, I think that mobile computing has entered, and we have to think about what to do with it. I think the kinds of things I didn't show you were the kinds of things that Walter Bender is working on, that Brian Silverman, I tried to get him to come, but I think turtle art is an example of a very compelling involvement for kids of all ages. It represents to me art and technology. And everything about logo was meant to be art, technology, music, creativity in the positive sense. And I think that's the kind of thing we need to continue looking at. How to make it easy and extendable for children.
Okay, anybody else? It's very hard to see actually into the...
There aren't any questions.
Well, there must be some questions. I've got thousands. I think. Ken, you want to?
Yeah, a great talk. So you mentioned briefly Alan Kay, and you know, Alan was very inspired by Seymour and set up the whole parallel effort at Xerox PARC, but also tried to push this idea of object-oriented programming. And I don't know enough about, I know a lot about both efforts, but I don't know how much they interacted or influenced each other.
Well, Alan came to visit us just before he went to PARC. PARC is Xerox PARC, the famous research place in California where Ken worked. He decided that when he began to build Smalltalk and the Smalltalk environment, that it had to include graphics, text, music, animation. Now, Alan also imagined, he was a musician, he was a painter, he was all of those things. So he built very high-end material for use. It was beautiful. But there was a lot of interaction between the groups. Does that make sense, Ken? Can't see you.
He's over there.
Oh,
yes.
There you are. Does that make sense?
He's just waving. No, you haven't got anything else to say, right?
And so when I wanted to do something, I wrote him a one-page proposal for the Atari Cambridge research lab, because Alan liked short things, still does. But it was a multi-million-dollar setup. I was very good at spending money. We bought Lisp machines. We developed, there was a little blurb I cut off. We developed an object-oriented logo. We were planning a PlayStation of the future for kids. And we were going to use color vector graphics. We were really zooming. The lab only lasted 2.5 years. Atari was sold and cut up.
But not before I had one myself.
The other thing is that force feedback joystick, several of the Atari people became the first graduate students of the Media Lab, Margaret Minsky being one of them. And she did her thesis with that force feedback joystick on haptics. So,
you keep that.
Okay.
Cynthia?
Yes.
Yeah.
Oh, Jose, yeah.
Yes. I remember the first time that we took the computers, the 3500 to was Newton schools, Brookline schools. Were you involved with that?
No. You can talk about it.
No, I was just going after class. I never been the.
There were two things. The 2500 was only a logo terminal, and then it became the 3500, a full-blown computer.
Yes, please, over there.
Good morning. My name is Seymour. I have some question. I will ask by Thai version, and Mr. Roger will help me translate. คือตัวผมเองเนี่ยมาได้รู้จัก Constructionism เนี่ยตอนที่ผมทำงานมาแล้ว20 ปีแล้วผมก็ได้กระบวนการนี้ช่วยผมในการ พัฒนาวิธีการทำงานซึ่งมันเป็นการจะพัฒนาให้งานของผมเนี่ยดียิ่งขึ้นได้ผมภูมิใจที่ผมได้เจอมันแต่ผมมาฟังงานนี้เนี่ยผมอยากจะสอบถามว่าในบริบทของที่ทาง MIT หรือทางทีมผู้เชี่ยวชาญเนี่ยได้พยายามพัฒนา Learning Tool ตัวนี้ไปในเด็กๆซึ่งก็คิดว่าเป็นสิ่งที่ดีผมอยากจะสอบถามว่าท้ายสุดแล้วเคยเปรียบเทียบไหมว่าตลอด40ปีที่พัฒนามาเนี่ยคนที่ถูกพัฒนาด้วยวิธีนี้กับคนที่เรียนด้วยเกณฑ์ปกติเขามีความแตกต่างกันในสังคมไหมอะไรคือตัววัดตรงนี้ฮะ
Okay, so he's a person who has been using some of the tools that we see here today in the slides, and it's very fascinating to see how it got started. And as a person who's been using it for a while, now knowing that it has been developed for so long, he was wondering if there's a way or any study to compare how those children who have worked with these ideas back in the early days have developed. Is there any kind of like evidence that shows the difference or like the benefits of these practices that we can access?
Well, Jose mentioned the Brookline project, which was a 3-year project. I wasn't involved with doing kind of an assessment. The kind of feedback I got was like in Exeter that summer, 2 of the young men, it changed their lives. One of them was Jonathan Pledge, and the Pledge algorithm is written up in Hal Abelson and Andy DeSessa's Turtle Geometry book. And then there was another young man who got in touch with me quite recently, and he told me he's a programmer and that it changed his life. So that's the kind of, I suppose, anecdotal story I get a lot of. And I get a lot of that from college students who tell me when they were in the 5th grade, they played with Logo and it changed their lives. So that's what I get.
Isn't somebody going to say that's not enough?
Come on, ask me a question.
It's gone quiet.
Good.
Okay, Walter.
So if you took the sum total of all the computers you showed us in your presentation and all the I/O devices and sensors, there's maybe 1/100th of the capacity that's in my phone today. And yet we see the remarkable things that those kids were doing and the poverty of what's going on in my phone. So help me. I'm not sure what the question is. It's maybe more of an observation and a frustration.
I give a lot of credit to Marvin and Seymour. What? Yeah, I give credit to Marvin and Seymour and the kind of culture, and this is what we were talking about. There's a kind of computer culture which grew up around thinking about Logo or programming or with children that is missing in a lot of places. The motivation, the guidance, my motivation was always, how can, when I introduce a child, how can I introduce them to be able to do something they couldn't possibly have done without a computer? And I think that the ways computers are being used today in schools is dreadful. It's, office skills for 1st, 2nd, 3rd, 4th graders, who cares?
Okay, there's room for one more. Yes, please. Before you start, can I just find out, is there anybody else who wants to get in the queue? Okay, so we'll have...
Right
You and then Anna, and that's it. Okay.
I guess my question, comment, observation is just an extension of what Walter was saying, except in terms of, every child nowadays has some kind of computer. So multiple computers. If you add, they've got computer games.
Not every child.
Well, I mean, in a comparison to when you started, the scale is.
Well, one laptop per child shows us that it isn't every child. It's a parochial view of the world.
Well, how can we make the devices that so many children have invite them into a culture of coding rather than thinking of themselves as just users? Because I grew up with a computer in my house, and I played a lot of games on it. And I never actually made the connection that I could contribute to the design of the computer for the longest time. I think the first time I kind of had a hacking experience was with Doom, where I learned I could make levels, but I never, unfortunately, had an experience where I thought I could contribute to actually, making code and actually designing something.
Sorry to push you. What's the question for Cynthia?
I've got it.
You got it? Good.
I got it. And that is, this is what this conference is all about. Yeah. I don't think there is an answer to that. We're still searching for it. How do we help children use things that are both fun and growing? I don't have an answer.
Okay, Anna.
Hello. First of all, thank you so much for sharing your history with us. It's fascinating. And you mentioned this, the way computers are being used now is dreadful, and your comments on how you used your computer. And I just wanted to share a little anecdote of a child I was working on with about 5 years ago, who is a 13-year-old in a public school in Mexico, and he was programming in Logo. And I said, why do you like Logo so much? A lot of people, because this was classic Logo, not Scratch, not, just classic Logo. He says, I love it because it makes me think, and it's hard, so that hard fun. And he says, but then he ended by saying, but I think that's why I don't like Office packages or pointing and clicking, because I think pointing and clicking makes human beings obsolete. This was a 13-year-old in Mexico who said that. So I just wanted to share that.
I just thought I'd show you. Circus arts were a very important element when Seymour and I were working with kids. We taught them to juggle, walk on stilts.
Microphone.
Oh, juggle, walk on stilts. And here's Seymour on a bongo board, and I'm pushing him. I can show you. Oh, sorry.
Oh, yeah.
I can't do this.
I know, it's because we have split screen. Hang on.
Ah, there it is. It just, for a second, you can see. No, that was 1970. Seymour and and there's only one other thing I will quickly show you. And that's this. Can you click on that?
Oh, wow.
Last summer I did a workshop. Turtle art is a programming environment where from very simple structures, beautiful artistic things can be created, and you'll be able to see some. So I've had the pleasure of being invited here along with Brian Silverman and Artemis Pappert, Margaret Minsky, and Oliver Steve.
I'm Artemis Pappert. I've been invited here in Jamaica by the Mathland Foundation to help in the Girls Can Code camps.
Oh, hello. My name is Dina K. Johnson. I live in Makaga Gardens down here. And right now I'm on Turtle Art. I created these on Turtle Art. It was a lot of work, but I kind of like the coding camp. So, because the teachers are very nice, I'm learning how to create art with a program because I really like art. And I'm having fun at the same time. Now, this is what I call Turtle Illusion, my first making. This is Angels. If you just look through my slideshow, you'll see all that I made.
What a great piece of video to finish the presentation with. Thank you very, very much, Cynthia. That was a wonderful contribution. Okay, but stay where you are because... Oh, wait. Are we ready? Okay. So, Cynthia, we wanted to thank Cynthia in a more tangible way, not just for her contribution today, but over decades that you've just seen. And we're doing that by offering her, on behalf of our community, a Lifetime Achievement Award. This is the point in the Oscars where everybody bursts into tears and, you know, cries and all that kind of stuff. But we're not going to... There are, in fact, 2 Lifetime Achievement Awards. And the first, I only have the vaguest understanding of, but Gary Steger is going to orchestrate it. Gary, I know you're a shy person, but could you come up to the front?
Constructionism conference, it needs to be debugged because the button isn't doing anything. But I figured there's enough talent here to make that go, and if you can't trust a $3 fairy wand, what can...
Well, there's a Lifetime Achievement Award for you. Thank you. And now, somewhere is another award. Yes? Oh, we're doing well here. Can I read the... Oh, this is for the cameras. Yeah, could I just read out? Okay, well, I'm sure Cynthia's going to show this to anybody who asks her for it afterwards, but it says, Constructionism Lifetime Achievement Recognition has been presented to Cynthia Solomon for her lifelong contribution to the field. And there's a wonderful photograph of her, which looks pretty current to me. Okay, so congratulations, Cynthia. We're just going to tell you where that award came from, aren't we?
One of the funny things Marvin Minsky did in his younger days is he spent time with another very famous computerist, Claude Shannon. And Claude Shannon and Marvin came up with the most useless box in the world. I have a video of somebody. What it is actually Marvin designed it and Claude built it. And it's a box, you turn it on and a hand comes out and shuts it off and goes back in. People don't know, but that's Marvin and Claude Shannon. Claude Shannon was the father of information theory. That's what he did, he played.
Okay, I'm completely confused about how many awards there are. Are you going to say something about the award from your university?
It's the gift from the foundation, Thaikom Foundation and Siksa Patana Foundation to your presentation. Thank you.